Hello, friends. Welcome to Science Talk. I'm your host, Jim Masso. I want to discuss with you here what we see. And this is from the webpage Scientists Warning, in cooperation with the Alliance of World Scientists. And they refer to the Blue Ocean event, acronym being BOE. And the Blue Ocean event refers to open Arctic oceanic waters. In other words, the loss of sea ice. So this article is really about the Arctic in crisis. So you can go to scientistswarning.org. It's the website there. And you can scroll through their look over their website and find articles to discuss. So here we have a polar bear sitting on ice. This is liquid water. There's all these little bits of ice here. That's a bird flying past. Looks like there's a little bit of algae right there in the ice, but this is it. This is a rather tenuous situation for this bear. Not used to having so much open water all the time. Happens in the Arctic does not stay in the Arctic. Paul Beckwith. Now, I have also been saying this very same thing for many, many years. I just never put it out on a platform before. But it's true. What happens in the Arctic does not stay in the Arctic. It affects the rest of the planet. And we're seeing that. As an example, the meandering jet stream becoming more meridional, dipping down because of the changing temperature. Temperatures increase in the Arctic. There's a less temperature gradient, which means a less pressure gradient. So the flow starts meandering. So the Arctic is in crisis. Jarvis Cocker is the author of The Guardian, who wrote The Iceman Cometh. Of the Arctic sea ice, 75% has been lost over the past 30 years. 30 years. Last year's sea ice level plummeted to the second lowest since record began. And I just I did a video earlier where I discussed what was going on with gases and temperatures and ice. And at the time when I made that video, the sea ice in the Arctic was the second lowest, second after only 2012. Well, I just saw recent data that the sea ice loss this year is the most, surpassing the ice loss of 2012. Other research is also reporting that the Arctic is in free fall. A new paper at the journal Climate suggests that the Arctic may be essentially ice-free during summer within 15 years. We used to hear 2050. Other studies are now warning that we may have underestimated the pace of the melt due to inadequate modeling methods. Let me pause there. The models that have been done have always assumed a linear aspect of change, that things were going to change in a linear fashion. We're now learning that things are changing in an exponential fashion, which hence the underestimation. We're getting dangerously close to losing this ecosystem due to human activities related to limitless growth economy, and with it our cool, because the Arctic does cool down the planet. Sunlight reflecting off the sea ice, that energy goes back into space. Now you have open water. Now that energy gets absorbed, warms things up. I like the poke here at capitalism. Limitless growth economy, because capitalism is predicated on two very bad assumptions. One, resources are limitless, infinite, and all that matters is growth. Wrong on both counts. Resources are finite. Continual growth with finite resources and finite space is a recipe for disaster. Okay, let's look at what's called the Arctic death spiral. And that's this figure right here. Let me see if let's first describe it. It refers to a scientific chart generated from satellite data in order to visually depict the disappearance of Arctic ice since 79. The circle, right, all this here. So let me see if this will load up. From the Skeptical Science, and typical slow upload speed here at home. Okay. And this, by the way, is from Biomass. They are an Arctic Research Institute. And what they're looking at here is starting at 79, going in a clockwise manner through the years, up through the latest data, 2013. Okay, for at least what this one is charted on. Now, you have the different colors here representing the months of the year. September is black. September, you'll notice, is the smallest. In other words, this is the month you get typically minimum sea ice because that's the oceanic summer. So it makes sense. And March, April, May, that's this grouping out here. That's typically your oceanic winter, so it makes sense you're going to have the most ice there. Now, they're given this as Arctic sea ice volume and 10 to the third cubic millimeters, cubic meters, excuse me, not millimeters, cubic kilometers. That's what that is. We've got 10 to the third cubic kilometers. And what do you see here? Basically, the 0, 5, 10, 15, that's the cubic kilometers right here. If you look at 79, let's just follow the April. You can see that it's about, say, 34 times 1,000. So 34,000 cubic kilometers. And as of 2012, it is about what, 22,000 cubic kilometers? That's a huge drop. Look at in September, when the ice is at a minimum, it's about 15, starting at 79 times 1,000, and it's under 5, almost at 3, nearly 3,000 cubic kilometers. And of course, everything in between. This is what they're referring to as the spiral. It's just spiraling into zero. And this shows from 79 to 2013. Again, you can see that the peak is during April, May with the oceanic winter, and then it comes September is at the minimum. So it basically makes this little sinusoidal, like a sine curve and so forth. But as you can see, over the years, it just gets less and less. Here's another Arctic sea minimum volume, okay, in 79, almost 17,000 cubic kilometers, down to a little over 3,000 cubic kilometers by 2012. So we're seeing a huge loss in the Arctic of the ice. If you extrapolate this out, you can even see when it will hit zero, which means totally open ocean water, not a good thing. If we lose the Arctic, we also lose the jet stream. The troposphere will expand, causing droughts and fires on many continents. What is going on the planet now as I'm recording this on September 16th? What's happening right? We had the West Coast fires. We got Australia. We had the Siberian fires. Don't forget, there were fires in South America and Africa that didn't get reported. Basically, there were major fires on every single continent, except for Antarctica, this year alone. Food production will be threatened. I've done videos on that. We may well be on the way to a hothouse Earth state in a 4 to 7 degrees C. We get huge storms, mass extinctions. Notice the same 4 to 7 C. No longer, it used to be 3 to 4 by 2100. I did a video segment about lessons from the early Eocene, where I stated that some models are saying we're going to hit 7 to 9 C by 2100. Well, 4 to 7 now is kind of the new thinking. That's 80 years away, folks. James Lovelock, Mr. Gaia Hypothesis himself, has been saying for over a decade that 6 billion people could perish by the end of the century. This goes back to what I keep driving home, the point that there's just simply too many people on the planet. Even putting aside what's going to come down the pipe from climate change, just resources alone. Resources where we could be unleashing unknown pathogens from the Arctic as the permafrost thaws. Yeah, this is stuff that's going to come down and it's going to massively correct how many people are on this planet. For those who say, "Oh, we can hit 13 billion by the end of the century," no, I don't think that's going. I don't see that happening. Climate change, climate refugees that will be created, starvation, disease, and there's going to be wars erupting. Yeah. I would actually say what he's basically saying, 6 billion people, that's 3/4 of the current human population. It may go higher. Scientists estimate that 150 to 200 species of plant, insect, bird, and mammal are becoming extinct every 24 hours. That's on a daily basis. Arctic sea ice volume was 47% below the 79 to 2018 average in this data set for July 2019, which is now a record low. It is on track to set more records in 2020. So let's see, the following animation shows changes both sea ice volume, which is the vertical bar, and sea ice thickness. So let's see if we can play this. Okay. Now, okay, see how the sea ice volume has really shrunk down from below? Now I'm going to play this again, and I want you to look at the colors here, and I'll explain why. This is basically telling you the sea ice thickness, which of course relates to volume. Let's do this again. It's going from the yellow down to the purple. What this is telling us is that we're losing multi-year ice. That's what it's saying. So instead of having ice that's 3, 4, 5 years of age, we're getting ice 0, 1, maybe 2 years of age. So we're losing multi-year ice. That's what that's telling us. Data shows that the rate of Arctic sea ice decline has slowed compared to 2012, which still holds the record for the lowest annual extent measurement. That, as I just said, I just saw data like yesterday that we've gone past it. And our old friend Zach Labe at the Department of Earth Systems Science, University of California, Irvine. Well, he is now at the University of Colorado Boulder, where he's on his postdoc. He's been doing the incredible work tracking all this developments and sharing with us what's going on. But we've seen sharp falls and rises in Arctic sea ice in early 2020, like back in March. According to NSIDC, which is National Science Ice Data Center, also located in Boulder, Arctic sea ice extent, the area where ice concentration is at least 15%, reaches the parent annual maximum on March 5th, 2020. And on March 24th, NSIDC reported that the 2019-2020 growth season had an exceptional finish, 5.61 million square miles or 15.05 million square kilometers, the 11th lowest maximum in the 42-year satellite record. Now let's go move over to Arctic record high temperature anomalies. According to researchers and climate reanalyzer data, the forecast for February 2020, okay, shows surface temperature anomalies reaching both ends of the scale over North America. While the Arctic is 3.5 degrees C, warmer than 79 to 2000, due to this heat and Arctic amplification, which means positive feedback loop, some researchers are saying the Arctic sea ice extent is falling, and it may be that Arctic sea ice has already passed its maximum extent for the year by February 9, 2020 at 14.03 million square kilometers. Okay, if you want the fine details, scientistswarning.org. Just go right there. Now, this is what I want to discuss. What is the Blue Ocean Event, the BOE, which I started this video segment off with? Excuse me. One of the big questions about global heating is when or if the Arctic will be ice-free each summer. Scientists such as Paul Beckwith have recently come to refer to this as the BOE. As the Arctic sea ice gets thinner and thinner, a Blue Ocean Event looks more imminent every year. Generally, scientists define a BOE as a complete absence of Arctic sea ice. Common threshold is when the area is less than 1 million square kilometers. This will allow the heat of the sun to fully penetrate the open waters of the Arctic. Is that we're on pace so that you get less than 1 million square kilometers of ice, if not right close to zero, then that's the BOE. And then you're going to just have a lot of heat being absorbed by the oceans, and that's going to cause problems. We know that the extent of the sea ice has declined. We know the prevalence of multi-year ice is declining. We know the volume is declining. We know that it freezes later in the year, melts earlier in the year. We're seeing all these things, and this has been a trend over the last 40 years. So the abrupt changes indicate that human activity has nearly melted an ice cap the size of the U.S., 4 or 5 meters deep in just the last 3 approximate decades. There is almost no multi-year ice left. So unintended consequences, superwarming, known as polar amplification, increasing storm intensity, meandering jet streams. It is thought that Arctic ice melt beyond a certain point will not regenerate. Recent studies indicate that Arctic sea ice cannot, quote-unquote, quickly bounce back if climate change causes it to melt and further that. Sea ice coverage shifts over timescales of decades to centuries, so shrinking ice cannot be expected to return rapidly. Okay, this bit here about shifting over timescales of to centuries, that's a little reference to the Milankovitch cycles. There's a debate. Is the Arctic Ocean already past the tipping point? Tipping point is defined as a threshold breach for abrupt and irreversible change. Whether or not the tipping point has been passed, it is a danger to approach it at all. BOE is not considered a complete meltdown, just an indication of an impending one. A BOE would happen in the summer, yeah, and the ice will still refreeze in the winter. But if the ice becomes unable to refreeze in the winter, because the oceanic waters are so much warmer, it holds all that, it still has that heat. Remember, the specific heat of water is such that It takes a long time to heat up, but it also takes a long time to cool down. So if you heat that oceanic water to above 0°C, and don't forget, to freeze oceanic water, you have to go colder than 0°C because of freezing point depression due to the salinity. So you could end up with a situation that if it does not refreeze at all in the winter, then we're in new, excuse the pun, uncharted territories. And that it would be a really bad situation. If all the ice were to melt, there'd be nothing to prevent the Arctic waters from rising above freeze. I just said that. The amount of energy absorbed by melting ice is as much as it takes to heat an equivalent mass of water from 0 to 80°C. This is called latent heat effect of increasing open water pool. If you ever walk along a stream or a lake in wintertime and you see what looks like a little fog above the open water, that is the heat energy being released from the water into the atmosphere. That's latent heat. Now, in the ocean, we have areas called that are open water. They're called polynyas. It's a Russian word. And you start getting more and more polynyas where the whole Arctic is one big polynya. That's going to spell major changes to come. In other words, you don't have the ice reflecting heat energy back into space. You lose the refrigerator, the air conditioner for the planet. We could also lose the ancient lands of the ice and snow from when folks immigrated over from Beringia, the 11,000 relatively stable years of the Holocene. Okay. I've already touched upon this. Melting ice reduces albedo. That's the reflectance of sunlight energy off the ice back into space. And then you have open water that absorbs the heat energy. So we already discussed about that. The reduced albedo effect is responsible for about 25% of global warming, according to Jennifer Francis, a research professor at Rutgers University. The more the ice melts, the more algae blooms take over and create what is known as watermelon snow. Another one of the many feedbacks. Watermelon snow, I did a video segment about that. We're seeing this a lot in Antarctica. However, I'm going to put this out here. I've discussed this before in other video segments. Ice edge productivity is extremely important because when the ice starts melting, you get that little bit of stratification because you have that fresh water there. There's going to be nutrients there. That you lock that in there. That allows phytoplankton to start undergoing primary productivity. And then you get the zooplankton, secondary productivity, and so forth. If you have less sea ice, you're not going to have that ice edge productivity. Because, yes, there is a switch over to another group of phytoplanktons later in the season to undergo productivity. But in order to activate them, for lack of a better word, the sun has to be at a higher angle in the sky. So if you don't have the sea ice, but the sun is still too low, you're not going to get the productivity either from the phytoplankton that are found in this little ice edge situation, or the more open water diatoms that will come later on. So overall, your net productivity is going to be less. And there's one thing I'm not really seeing a lot of discussion about is ice edge productivity. So this climate scientist, Hadley Cells, and his colleagues quantified the Arctic ice albedo feedback and found it was substantial. We're getting hotter because sea ice is shrinking. Yep, that's probably as good a summary as you're gonna. You want one sentence? There it is. Now you can click on the Arctic sea ice figures. Let's do that here. And we can some of these This is a time series one here. Well, some of these here should be graphics that are similar to you, because I've used these. I've presented these to you before earlier. That I have done. But look at this one here. Look how it's boom, it's bottomed out. And so you got the blue line, which is the measure, and then this is 95% confidence interval. So we'll go back to that. Why is the ice melting? Well, clearly from rising global temperatures due to humans burning fossil fuels. Okay? And that's even the NSIDC stating that point blank. It's important to note that just because it's cold outside or we get a snowstorm does not mean the polar regions are not warming overall and decline. And so they have an article that happens discuss what happens with a warming Arctic is linked to extreme cold and heavy snow in the U.S. Okay, I think I can summarize that for you because I've done videos on this. You're changing the jet streams. So now the jet streams start becoming more meridional. So they dip down. Well, they dip down. They're bringing the cold Arctic air with it. Cold Arctic air with some moisture in it. It hits the warmer air at the lower latitudes, creating a precipitation event. Also couple that with what's going on between the Arctic Oscillation and the North Atlantic Oscillation, and you can create conditions where you get heavy snowstorms. Also remember, warmer air is going to hold more moisture. So if the air is warming up, you can hold more moisture, and it will still come down to snow because, hey, the axis of the Earth is tilted away from the sun. You know, you're still going to have the seasonalities. So, that's basically a quick, quickly what's going on. And we're seeing that. And of course, you get the climate deniers saying, I got 3 feet of snow outside. Global warming is bullshit. No, it's happening because of global warming, because we're sharing with you a wonderful polar condition down to mid-latitudes. Enjoy. But that's really what's going on. It's the changing jet streams. And if you have open waters, and you got that latent heat dumping the moisture into the atmosphere, it's going to bring that moisture down to lower latitudes, where then it precipitates as a shitload of snow. Okay, so let's discuss what polar amplification is. Paleoclimatology records show evidence of polar amplification, both from the Arctic and Antarctic. Polar amplification is the phenomenon that any change in the net radiation balance tends to produce a larger change in temperature near the poles than the planetary average. It is the mechanism by which the poles warm at faster rates than at mid-latitudes, heavily influenced by various feedback loops. The Arctic is warming up at least twice as fast as the rest of the world. I am now hearing more and more, and I'm seeing the data that's saying more and more, 3 times faster than the rest of the world. Dr. Bethwood says 3 to 5 times faster. You just look what happened in Siberia, 100.4 degrees Fahrenheit they reached this past summer. Polar Portal shows temperatures north of 80 degrees north latitude, that the 2019 daily mean temperature is way up for October 2019. The temperature is now well above the 58 to 202 mean. And Elizabeth Barnes of Colorado State and her collaborators, colleagues, are the ones that investigating this. The Arctic temperature anomaly reports are consistently at least a couple of degrees above the 79 to 2000 database. Arctic sea ice is collapsing faster than expected. Recent research states that scientists think that several cryosphere tipping points are dangerously close. Cryosphere refers to anything that has ice. So snow, glaciers, sea ice, permafrost with ice lenses. That's basically what the cryosphere involves. Without the ice, our oceans heat up far more rapidly than they ever have since humans been around. It's a little tricky to kind of predict when the first BOE can expect to occur. That depends on the models that you're using and so on. Nobody knows for sure. Some people saying in 2022 will be a guess. Who knows? So let's see. BOE plus 2 years, the Arctic Ocean will be ice-free for August, September, October. BOE plus 4 be ice-free for 5 months. BOE plus 10, the Arctic Ocean will be free of sea ice year-round. That is very alarming. So the plus 4, plus 2, plus 4, plus 10 is referring to 2 years, 4 years, 10 years after the first prediction of 2022. So basically saying by 2032, the Arctic Ocean could be free of ice year-round. That's alarming. That's very alarming. We have this decline, long-term decline in Arctic sea ice, that spiral that I discussed earlier. But we're seeing a bunch of different scientists all stating the same thing. We're going to have a BOE event. We're not for sure when, but it most likely will be happening, and it will get more and more and more. So let's discuss what some of the consequences are. I've already touched upon some of them. Right? Obviously, open waters will be absorbing sea ice. I've already discussed with you latent heat effect. So a BOE means the beginning of the end of cooling, which means this will help accelerate the planet to some of the 4 to 7 to possibly 9 degrees C warmer by 2100, because we lose the refrigerative effect of sunlight energy reflecting off the sea ice. If there's no sea ice, all that heat's just going to be absorbed, and you're going to really accelerate the planetary-wide warming. Well, man, the gentleman who came up with the hockey stick graph, the Arctic is a natural freezer. There you have it, right? Get rid of the freezer, everything warms up. Climate weather patterns will be profoundly disrupted and unstable. According to the latest IPCC report, the coming consequences of the melting poles are nothing short of scary. For the IPCC to say scary, for them to even say, hey, we better get our act together, things are dire. They have always historically underestimated, downplayed things. Then, of course, you've got countries around the circumpolar north that are just waiting to, you guessed it, drill for oil in the Arctic Ocean, which is stupid. We can expect to see sea level rise. That's expected because you're going to be melting the glaciers, alpine, continental, what have you. You have thermal expansion as well. You're going to have feedback from various people whose livelihood depends on sea ice ecosystem. The Inuit populations, for example, they need the sea ice to go hunt for seals. Well, it ain't just polar bears having trouble hunting seals. Okay? A lot of them are having to deal with relocation. And of course, what it does, the feedback, the positive feedback loops it does to the animals themselves, the polar bears, the walruses, the seals. The seals need an ice place to come out and have their pups. The pups cannot swim when they're born. You go to the other side of the planet. I just did a video segment about emperor penguins. They need the sea ice to raise their chicks. The sea ice is disappearing. There's now concerns that by 2100, emperor penguins will be extinct. Remember, positive feedback loops do not mean it's positive, it's good. It means it's a runaway system, and it's not good. NASA is saying the ice loss in the Arctic will affect the Earth's obliquity. That is interesting. That's basically referring to the tilt of the axis. So that's really interesting. I guess all that weight will kind of change the center of mass. That would be my first thoughts on looking at that. Impacts of El Nino and La Nina, so ENSO, are also expected along with the meandering, more meridional jet streams, regularly disrupted polar vortex. In other words, a polar vortex dips down thanks to the changing jet stream, and you bring a blizzard to the mid-Atlantic states. Bubbling methane released from thermal cars or thaw lakes is also accelerating permafrost thawing. The ice melts, the ground thaws. Thermal cars are basically lakes. If you ever see photos, aerial photos of the Arctic, you'll see what looks like circular things of water. Those are the thermal karst lakes. It almost looks like craters that filled in. A lot of the thermal karst lakes are the results of pingos, where the pingo is a hill that's filled with ice. The ice melts, the ground slumps down into a crater, and then fills in with water. That's one form of thermal karst lakes. But as the permafrost thaws, methane is released, as well as nitrous oxide, further greenhouse gases. It ain't just CO2. Odd permafrost could contribute up to 1.7 degrees C of warming. A BOE has the potential to disrupt atmospheric ocean currents around the world. You change the jet stream, you change the wind forcing pattern. Winds blow on the ocean's surface, pushing the water, helping one mechanism, not the only mechanism, but one mechanism to help create currents, surface currents. Don't forget, if you put all that melting into the surface waters, you could slow down the thermohaline circulation, which will then affect, for example, in the Southern Ocean, where there's the Antarctic divergence, which is a branch of the conveyor belt upwelling, bringing nutrients that feeds that ecosystem down there. That ecosystem could collapse. And this is the issue of the methane burst, known as the methane time bomb, or clathrate gun hypothesis, or the melting glaciers at Novaya Zemlya, which are known to be leaking radiation from the Tsar Bomba detonation. Okay, I want to talk about methane. What really concerns climatologists, and concerns me, is the methane question.
So the question is, how much is in the ground? At what rate will it be released? You know, with looking at the clathrates, hydrates, and the permafrost.
We impolitely state this is the methane fart question. Ground farts or burps, depending which end of you want to look at, but basically you have a sudden release of a large quantities of methane. What will that do? Since we haven't experienced a BOE yet, it's hard to say exactly what the effect would really look like. Would this signify a point of no return? Okay, we don't know. We don't have the data yet. But we're very well on track for a hothouse Earth. Losing summer ice will drive significant regional warming. It may increase mid-latitude weather extreme, as well as disorientate the jet stream, with stuff we've already discussed. We have perturbed the system. And the system, in trying to find this new equilibrium condition, but with continual perturbations by humans, cannot find the new equilibrium state. And so we get chaotic responses. So you get look at what happened in Colorado recently. It went from like, well over 90 degrees Fahrenheit, and then a day or two later, it's dumping snow. So and then, a day or two after that, it's back up into the 70s. So you get these crazy extremes. That's an example of chaos theory due to perturbations to the system. To get into it. So just some of the possible consequences of a BOE and related climate change defined by James Hansen. Both wave action and Ekman pump action will increase the bottom water temperatures in East Siberian Arctic shelf. Okay. Ekman pump action. There's a thing called the Ekman spiral. And from the Ekman spiral, you get Ekman mass transport. The short of it is that as the water moves, as you push on the water, the net volume, the things are going to be deflected to the right due to Coriolis. If you integrate over the water column, the net transport is in the northern hemisphere 90 degrees to the original direction of movement. That's called the Ekman mass transport, which is a pumping action as well, because you're moving water over. So if you're moving water, you have to replace it from something else. This is a very lengthy discussion. If you're really interested in this, I did a video called Rotational Systems. I explain it there with lots of graphics to help visualize what goes on there. If you're interested, please check out that video. But the point of this is you increase methane emissions from the hydrate decomposition. That's the methane hydrates. That's methane and water frozen together. Permafrost decomposition will accelerate, increasing both CO2, methane, and nitrous oxide emissions. Boreal wildfires will increase, like what happened in Fort McMurray in Canada, what happened in Siberia, what happens in Alaska. Atmospheric thermal gradient will decrease, which will decrease the constraints on the jet stream, which will increase blocking events, increasing extreme weather events. Translation. Temperature gradient will be less, which means the pressure gradient will be less, which means the jet streams won't flow as fast, which means that if it's carrying a low pressure system, it may stall over a region and keep dumping its precipitation. That is in essence what happened with Harvey when it came ashore in Texas. The jet stream stalled and it just kept pissing away on Houston. Warming over Greenland will accelerate, which will increase ice mass loss, associated sea level rise, SLR. The specific humidity in the Arctic will increase. That's latent heat energy being introduced into the atmosphere. And water vapor is a greenhouse gas. That's what GHG means. Will increase Arctic amplification. One of the things that often gets neglected when we're talking about burning the fossil fuels, like automobile, when you burn an octane, which is a hydrocarbon compound where all the carbons are single bonded to all the other carbons, and it's only a carbon and hydrogen. There's the only elements in there. The product of combusting octane, which is a type of alkane, is you get CO2 and water. So when we're burning gasoline, we're putting not just CO2 into the atmosphere, but water vapor into the atmosphere. And water vapor is a greenhouse gas. Okay, so let's see. We're also going to see snow cover will decrease, acting as a positive feedback for more warming due to decreasing albedo. You warm up the air, you further thaw out the permafrost, further releases more methane, further warming, and so forth. Shrub growth in the tundra will increase, so you're going to see a transition from tundra plants to more shrub plants. So from very low to the ground plants to shrubs. That's because the more of the ground will have a ice-free zone. So in other words,
the thaw layer gets deeper, allowing the shrubs and later on trees that require deeper roots to become established.
The spruce bark beetle here in Alaska. It used to be interior Alaska was too cold for the larvae to survive. And so there was no spruce bark beetle infestations. Not so much anymore. Now the winters are warming. The larvae can survive. And they're now spreading out of the Anchorage Bowl into interior Alaska. Ground-burrowing animals, like ground squirrels, will move north, which will accelerate permafrost degradation because they're just chewing through they're burrowing around. That brings heat into underground regions. Farmland will move northwards, which will decrease albedo and accelerate permafrost degradation. Plankton growth will accelerate in the Arctic, which will be smaller in size than the current average, which will sequester less carbon. Okay, I'm going to question that one a little bit for reasons I outlined earlier. You have in the Arctic Ocean region, you have ice edge productivity and then open water productivity. They both combine for the overall productivity. But for the open water productivity, as I stated earlier, you need the sun to be at a sufficiently high angle in order for the sunlight energy to activate the chlorophyll found within the chloroplast. And without the ice edge productivity, you're losing that productivity. So I'm going to put a little caveat to that. But the point is, overall, you're going to have less total primary productivity, which means, yes, less carbon will be sequestered, will be removed. So that portion, I'm not going to argue with. That portion I will agree with. Plankton growth accelerating, I'm not sure about. That one is where I will question. The thermohaline circulation, that's the oceanic conveyor belt, will slow and convey more warmth into the Barents and Kara Sea areas. It will slow. Does it convey more warmth into the Barents and Kara Sea areas? There is evidence that the Barents Sea is becoming what's called Atlantified, which means it's starting to acquire physical characteristics more associated with the Atlantic Ocean water than with the Arctic Ocean water. But the way to introduce the warmth up there is from the Gulf Stream, which becomes the northward drift at that point. If the deep water formation is slowing, it's not going to pull the Gulf Stream with it. So I'm not sure about how that's going to warm the Barents and Kara Sea. The only way I see that happening is influx from the Pacific side through the Bering Strait is how I see that happening. So you would have the influx of Pacific water through the Bering Strait that can make its way, the East Siberian Sea, the Laptev, and then finally the Kara and Barents Sea. So that would be the mechanism that I can see this statement coming to fruition. Shipping will increase because open water, so you get more carbon emissions, and resource extraction will increase. Okay, so even more consequences of Arctic sea ice melt. Recent research is just linking sea ice retreat with tropical phenomena and changes at the equator, including a new kind of El Nino and a drastically meandering jet stream. We keep touching upon that, but that is very important. This further impacts the influence of Arctic sea ice variability on Pacific trade winds, which will affect ocean currents. It can also corresponds to sudden stratospheric warming, expanding tropical zones. What is the expanding tropics? As Earth's dry hot zones shift quickly to the poles, Hadley cell expansion will impact us all as the world warms. Hadley cells are cells that occur between 0 and 30 degrees latitude, north and south. And basically, you heat up the ground, the warm air rises, and due to convection and Coriolis, it moves north to south, depending which side of the equator you are. As it moves, it cools and sinks and then flows back in. So you get basically a vertical convection cell. You have the Hadley cell. from 0 to 30. Then you have the feral cells from 30 to 60, and then you got the polar cells from 60 to the poles. So, so the Hadley cell will expand. So it may push out the feral cells. Time will tell. Arctic ice changes ocean currents. While melt slows the AMOC, it can speed up local currents. Some models have suggested a warmer world would lead to a slower ocean. Certainly true for the thermal haline circulation, or the AMOC, conveyor belt is colloquially called. It's driven by cold water sinking, flowing southward. Its slowing doesn't negate the possibility that winds could increase other currents. That's a very true statement. But remember, conveyor belt is a heat distribution mechanism for the planet. So what about Greenland? Greenland is also melting, more than expected in the summer months. I've done a recent series of videos on this. Greenland's main glacier, the largest ice sheet outside of Antarctica, lost 217 billion tons of ice in 1 month alone, July 2019, releasing enough water to fill 4.4 million Olympic-sized swimming pools. Greenland's ice loss will contribute significantly to sea level rise, as does from Antarctica. It's now becoming widely known that Greenland's ice is melting much faster than thought. Again, think about the exponential rate of change. On average, Greenland loses 270 billion tons of ice each year, principally, basically between like June, July, August, and September. Other conditions: winter high temperatures about 45 degrees above normal in the last couple of years. The North Pole reached temperatures above freezing despite being in total darkness during the coldest months of the year. In addition, some areas of Greenland experienced open water for the very first time, and the Bering Strait was also completely ice-free for part of the winter. Don't forget, way, way, way back in the Earth's past, when the continents were in different locations, the Earth was a lot warmer, and that's because of how the heat was distributed around the surface of the planet. But when you look at recent times, this is the highest CO2 level. This is the warmest the planet has been. So you have between polar ice and Antarctica. You know, to talk about how the Arctic ice is a refrigerator for the planet. So is Antarctica. The planet really started to cool down significantly once Antarctica assumed its current location. Then the ice started building up, and then you had the albedo down there. There's concern that Thwaites, Pine Island, Brunt Ice Shelf, and Ross are all in danger of collapsing. If that happens, sea level rises will increase dramatically, but you're also losing the albedo from that end of the planet as well. So that's also another concern. Research shows that Greenland's ice is not just trickling into the ocean, but melting significantly in large spikes. I've done a series of videos on that recently as well. BOE is a phenomenon particular to the Arctic region, because the Arctic region is ocean surrounded by continents. Antarctica is continent surrounded by ocean. And as I just said, you know, Antarctica is losing ice as well. NOAA's reported January 2020 is the warmest on record, warmest January. February 8th, 2020, Antarctica recorded its hottest temperature, 64.9 degrees Fahrenheit, or 18.3 C. So we're seeing, you know, warming is there as well. Don't forget, February is their summertime in Antarctica. And then, I just talked about the Thwaites Glacier. They're now calling it the Doomsday Glacier. I'm reminded of the Doomsday Machine from the original Star Trek. It's the riskiest glacier. I'm not going to play this video because this video is already running long. But basically, the concern is that it's in fear of immediate collapse or imminent collapse. Large pieces broke off Pine Island. So, could marine cloud brightening save the Arctic? If things keep going, may be forced to try risky gambles with new technologies. So in his book, Farewell to Ice, Peter Wadhams suggests a non-toxic geoengineering technique called marine cloud brightening as a way to save the Arctic. Highly experimental, never been done on a large scale, and not much outside the laboratory either. Can we refreeze the Arctic? What about artificial glaciers? So scientists are looking at ways to refreeze in the Arctic. Again, for those of you who followed my channel for some time, you know my opinions about geoengineering. There are always parameters, always interactions not considered that happen and just throw huge piles of wrenches into the system. Geoengineering things never, in my opinion, never work. They are foolhardy. That's my opinion. I'm reminded of the 2 attempts at seeding the oceans, putting basically ferrous compounds, iron in solution, into the oceanic waters, because iron is a micronutrient that phytoplankton require. So the thought was, well, if we give them a micronutrient, phytoplankton numbers will bloom, and there will be more productivity, drawing down more carbon, and so forth. They tried it twice. It was a whopping failure both times. And we heard other things like, let's build a concrete wall around Antarctica to keep the ice there. You know, stupid, I'm going to be blunt, stupid ideas like that. So, here are some other links. Third pole is a reference to the Himalayas, by the way. So again, go to scientistswarning.org. Scientistswarning is one word, .org/2020/0604, and then Blue Ocean event. But so there you have it. The Arctic is in crisis, which means if the Arctic is in crisis, the planet is in crisis. If the planet is in crisis, humans are in crisis. Plain and simple. This is very stark. This is very serious. But this is what's coming. We are already seeing things happening, and it's just going to get worse and worse. And even if we were to somehow stop burning fossil fuels today, there's so much thermal inertia in the system that things will not begin to reverse for at least minimum 500 years, most likely 1,000 to 2,000 years, 1 to 2 millennia. So I thank you for your time. I encourage you to pull up this page here and investigate for yourself all the excellent information contained within here, all the videos and stuff. I probably would have tried to play more videos, but my upload right now is pretty crap, as usual. So, but anyway, lots of really good information on here, and I encourage you to explore further. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.